Good evening, good afternoon, everybody attending our first installment of the Geology Games. This is a series of learning games that we have started at Laurentian University, in which you have a chance to play as well for winning one of our new Minecraft-inspired rock identification games. My name is Tobias Roth. I am a technologist and geoscience instructor at the Hartwell School of Earth Sciences at Laurentian University. And joining me are our PhD student, Derek Loong, who I will ask to introduce himself as well. At this occasion, we will have a 45-minute session called Geology Games Crystal Clear, in which we'll learn about minerals. And Derek, being a professional mineralogist, will be able to answer questions in the Q&A. So we are located on the Laurentian University campus in Sudbury, Ontario, Canada, and we are on the traditional lands of the Atikameksheng Anishinaabeg First Nation, and we extend our deepest respect to all Indigenous nations of North America, all Indigenous peoples of North America. So thank you for being here and playing along and learning along. We will play a Kahoot. We'll have a practice Kahoot beforehand so everybody knows how to play that Kahoot. We will actually be able to play it with the app that you can download on your device, or you can go on any web browser that and type in the kahoot.it URL. So Derek, if I may ask you to introduce yourself, being a co-host here. We are located right now at Laurentian University at the Hartwell School of Earth Sciences, and we'll play very shortly.
Hey, so my name's Derek. Sorry, Tobias, could you enable the video from my video? It seems like it's disabled.
Okay.
But it's okay. I can continue. So my name's Derek Leung. I'm doing my PhD currently at the Hartwell School of Earth Sciences. I also did my undergraduate degree here as well. And then I went to Scotland for a year and a half to do a master's, and now I'm back in Laurentian. So if you have any questions about the program, any questions about minerals or rocks, I'm happy to answer them. And yeah, that's pretty much everything about me. To use the if you have any questions, you can use the Q&A function that should be on the menu on the bottom, and then you can ask questions, and then I'll be happy to answer them for you. And if Tobias wants to answer them in person, he can also do that as well, live. Yeah. Oh,
thank you very much, Al. I'm still not able to see that. I wonder if Lynn, a good colleague Lynn, also is able to see the appearance for Derek. Yeah, I think I just found the button. Thank you for bearing with me. I can just make you a host.
All right, it works.
There you go. Thank you very much for joining us tonight, and thank you for your introduction. We will start by myself putting safety gloves on, because there are some really fragile samples that we want to share with you under the microscope. And at some point, Derek, I will ask you to speak about our school, because we will I will have to recable my setup. There's a microscope attached to my screen as well. So let me show you one really fragile sample here. This is a mineral or crystal. You can see this is what I'm holding. It is actually a sample that is from a mine called Wieliczka in Poland. It is halite, and what you see here are two substances, two earth materials. One is a piece of wood. It could be fossilized wood, and on top of that, minerals of halite have crystallized, very, very delicate. And I just want to introduce yourself to the science of mineralogy. It is a subdiscipline of geology, and geology is also known as earth sciences. Hence, we are known as the Hartwell School of Earth Sciences. We're teaching this science since 70 years. And our graduates are going all over the world practicing geology. in very different subdisciplines. So the mineral I've just shown you is appearing in very different ways. You can actually see on this picture a crystal that's looking a bit different, but it has a very certain geometric shape. And that shape is a reflectance of what this crystal is made up on the microscopic scale. So you see at the bottom, there's this model that is in the shape of a cube that shows you that these sodium and chlorine atoms are connected together to form this shape. And you can see that shape on the outside as well. So the definition of a mineral, and this is any mineral in the world, halite and the 4,000 other known minerals that are pretty much made of small boxes that are connecting together in a certain way. And this one is also known as salt, right? Halite is salt. So in the meantime, just making sure that I'm mentioning everything. The wood that you would have seen on the same sample is actually not a mineral. That is an organic substance that has no inorganic. That's a requirement for it to be a mineral. So what we have in Canada is a lot of ice, a lot of water, and that water, when it becomes ice, it crystallizes. It is an inorganic substance, and thence it's a mineral. So that is the definition that we want to do. I do want to go and test a Kahoot with you. Practice Kahoot, no pressure. There will be a 7-digit game pin. No music yet. There will be music in the next one. So you can name yourself anything. It doesn't have to be your real name, but we all love creativity. I'll interrupt the screen share for just a moment. Very good. So we will start in about 20 seconds. Let me know in a Q&A if we need to wait a bit longer. All right. Here we go. Just 5 questions. Sometimes true or false. Look at the pictures as well. That will help. Trial for Geology Games. Not the real game yet. Are we ready to go? Very good. Next question. It's going very quickly. 10 seconds for every question. Perfect. Everybody's got it right. We'll breeze through this one and then we'll learn some real things. Just a note to Derek, I will then recable my microscope. So speak about your experience as a student. So let's warm up all those cell phones and hands, because speed is of the essence, as you will have noticed by now. And yes, this is our local landmark, the Big Nickel. Thank you very much. So this podium does not count, but I can tell you right now that with the final Kahoot played at 4:30, there will be the podium. The people standing on the podium will win one of these boxes for every person who's on that podium. So I will then ask you for your mailing address. You can also email that to me. You can find me on hes.laurentian.ca. Derek can also be found on hes.laurentian.ca. This is our new Minecraft-inspired rock identification game. And yeah, I forgot one question. Do you want to win one of these games? So here's that podium for the trial run. All right, congrats on that trial run. So Derek, please let us know about your experience. Was that music actually audible? Was it audible?
I didn't hear the Kahoot music, but
No,
I think it was
okay.
okay. Yeah.
There's some kind of a glitch. Okay, we're trying to fix that.
Yeah,
I'll mute
so
myself.
as Tobias said, my name's Derek. Sorry if my camera lags a bit. I tried to get a new camera, but I haven't gotten that set up yet. But yeah, before we start or before I talk about my experiences, I'd like to know a little bit about you. So if you could just go into the Q&A and tell me where you're tuning in from, and maybe what your favorite rock is, and why you're here, that would be pretty cool for me to see. For me, I've been interested in minerals since kindergarten, so a very, very young age. And I'm from Toronto, so I grew up just around in the 401, 404 corridor. And sorry, I'm seeing some of the answers from our second year students as well here. And yeah, I've been interested in minerals for a very long time. I joined a couple of rocks and minerals clubs when I was in about grade 1 to high school. And then I pretty much knew that I wanted to be a geologist and a mineralogist. I'm also a competitive curler. So if you've ever seen curling, it's the sport with the stones, and those stones are slid across a sheet of ice. And those stones only come from two places in the world. There's a place in Scotland and a place in Wales in the United Kingdom. And so for my undergraduate degree, I went to Laurentian, and I really liked it here because of the small class sizes. And also, so because of the small class sizes, I was really able to have a sort of a close relationship with a lot of my professors. And yeah, I had a great time. It's one of the best universities for mining and for geology related to hard rock mining. So I had a great experience here so far. And now I'm back for a PhD because clearly I can't stay away from Laurentian.
Thank you very much. We're happy to have you, Derek. So I will try my microscope share. There's just one little issue still. No, it's not working yet. Oh, here's that cable that I'm needing. All right, so we will talk about the mineral properties. So pay attention to what these properties are. What you see under my screen here is that same sample from Wieliczka, Poland, where we have crystals visible that have evaporated. You see those flat sides, they're called crystal faces, and they're all stuck loosely to that piece of wood. Now, when you break halite, you will actually be able to see that halite produces flat surfaces even when broken. So one example here, the iodized salt from the cafeteria will hopefully also resemble those crystals. So the crystal faces for halite are the same as the actual broken, crushed pieces that we see in the salt in the cafeteria. So that is important because every time we break a mineral and we use this hammer, this is the hammer that I brought along on that hike that inspired me to make this Minecraft-inspired rock identification game. You can imagine a hammer can produce many of these pieces that then show cleavage planes. So halite, being a cube, has 3 cleavage directions, but you can actually try breaking something like mica with a hammer. So this mica is very flat. It only breaks in one direction, so I can peel them apart and have like tiny flakes falling onto my desk. And you can look at those tiny flakes under the microscope as well, that they only break in one direction. So very, very thin sample that as opposed to halite only breaks in one good cleavage direction. So a very important mineral we have is also quartz. So quartz, just like halite, has flat sides. So let's look at this piece of quartz. Here we have flat sides, but also a few chips. So this quartz was broken, and when you break it with a hammer, it does not actually produce a flat surface like that halite cube from the cafeteria before. It produces irregular surface, like you can see over here. That is actually conchoidal fracture. So when it's not flat, it's called fracture. And we see that fracture with other samples, such as the small piece of fool's gold over here. So zooming into that, you see the crystal face on the surface, but it does not have a good cleavage direction. It makes these irregular surfaces wherever this pyrite cube is broken. And therefore, we have a mineral that is fracturing rather than cleaving. The next mineral I want to show is calcite. But let's remember quickly, those flat sides we saw so far are sometimes crystal faces, like this pyrite. There's a bigger piece of pyrite that's actually not broken up like the smaller one, has a tiny chip. And these crystal faces form when the mineral crystallizes. And the other flat sides that we saw, for example, in that halite or in this calcite, form when you break the mineral with a hammer. And this is representing a plane of weakness inside the crystal structure. So whenever you have a crystal structure, it has some kind of weak directions along which the ionic bonds are easily broken. Therefore, that mineral will cleave. So let's see, the calcite looks quite differently. It does not resemble a cube. It's more like a rhombohedral shape. And it will also exhibit some other properties. For example, good, I have my gloves on. I also need my safety glasses for this occasion. That's when we treat calcite with hydrochloric acid. This is diluted, not very dangerous. And we'll need 1 drop on this calcite to show us a mineral property we call effervescence. It just is that fizzing that we will be able to observe. So this mineral will give off a gas when you pour hydrochloric acid on it, meaning that the mineral will start dissolving and release carbon dioxide gas. The other properties that calcite has is double refraction. We call it optical calcite sometimes, or Iceland spar, or we will also actually use it in microscopes, some of the microscopes that we use here. Now, really cool thing about calcite, we are speaking a lot about green technologies lately that have to do with our daily use of minerals. So we need metals, for example, and what we have here is a new way of using calcite, the mineral that we have under the microscope, for a green technology we call carbon capture and sequestration. So that CO2 that is being released from the mineral calcite is then being put back down into the ground. And this picture is from Iceland. So this woman is holding a vesicular basalt rock found in Iceland that can fill its pores with calcite. And what they do there is they have these large plants that suck the air out of the atmosphere, and they enrich the carbon dioxide and mix it with a slush that then becomes crystallized carbon dioxide, if you will. In the end, it's really just calcite, but it is better to have greenhouse gases like carbon dioxide in the ground than in the atmosphere because of global warming. So this is one example of a green technology that we use nowadays to alleviate the strain from global warming. And it is still lots of research in that regard, but I just wanted to mention that. So another mineral that is kind of cool. So when it comes to mineral identification, oftentimes we look at minerals from Minecraft. So the calcite is actually a mineral that is found inside the box that you could win, along with the quartz. And another mineral that is actually not, it's pretty widespread, but it's not inside Minecraft yet, is gypsum. This is one of the softest of all the minerals. So you can see when we as mineralogists or geologists are looking at mineral properties, one very important one is the Mohs hardness scale. And that has a scale of 1 for talc, 2 gypsum. Those are the 2 minerals that you can actually scratch with your fingernail. And the other ones get harder and harder. So we've got calcite, fluorite, up to diamond. So this is the Mohs hardness scale. And I just wanted to show and prove to you that this piece of gypsum can actually scratch by a fingernail. You see a couple of scratches on the not so nice side. So this is the not so nice side. You can see it's been scratched with a fingernail before. I just wanted to mention hardness. And we also want to see streak. So streak is using a ceramic plate like this that you can actually scratch a mineral on, and it leaves the powder of that mineral. In this case, it's the pyrite in its golden color, leaving a black streak. So the powder of pyrite, counterintuitive, is not gold looking, it is actually black. So a different type of color. Let's look at the different shapes that minerals come in. I think we have covered so far all the important characteristics like effervescence and cleavage, fracture, hardness, streak. And let's look at a couple of these 3D printed shapes. And you may remember which mineral has this shape here. This is a cube, and we have a hexagon visible on top of this shape. This is also 3D printed. And I'll show you the shapes first, and then I'll show you some minerals that correspond in no particular order. This is a prismatic mineral with a hexagon on either side. Here we have also a prismatic mineral, but this one has 2 pyramids on either side. And it's called a dipyramid, standing for 2 pyramids, one on either end. Over here, we have a shape that resembles gypsum. So that's gypsum that I have shown you before. And over here, it's a dodecahedron. Ask yourselves. So this dodecahedron has many rhombic sides. And how many are there? There will be 12 in total. Over here, we have an octahedron. An octahedron is composed of, has 8 sides that are triangular. And the last shape I want to show you is the one that is a rhombohedron. So it's got 6 rhombic sides. Note that it actually is a mineral. It's analogous to the mineral that has 3 cleavage directions. So it being three sides, you've got a cleavage direction at the top and at the bottom, one on the side, and the other side is the same direction, and one in the front and in the back. So those front back is one direction, left right is one direction, and bottom top is the other direction. So three directions of good cleavage for this type of mineral, and you've seen it before. I hope you remember what it's called. The other minerals that I need to show before we start the Kahoot in 2 minutes will be fluorite. Here is fluorite that is being used for making hydrofluoric acid. So I've shown you hydrochloric acid before. This is not a very strong acid, especially not when it's diluted. It can be a strong acid, but hydrofluoric has some more precautions that one would have to take, because what we actually dissolve in hydrofluoric acid is rocks. We can dissolve rocks with hydrofluoric acid. Hydrochloric alone cannot do that. And the mineral fluorite resembles one of those 3D printed shapes I had shown you before. The quartz also resembles one of those 3D shapes. And this mineral here is also resembling one of those 3D shapes. So we're looking at the green mineral that is sticking out of orange calcite in this case. And the very last mineral, one that comes from Mexico, it's a grossular garnet. You will see that it has crystal faces that reflect the light. See what shape those are in. They will give you the clue as to what the shape is being called. So I think that pretty much covers everything we need to know for the Kahoot that we want to play right now. Just a little recap to show you what we've seen so far. So we have looked at various minerals. So these are the minerals that we've looked at. I've mentioned the halite, the quartz, the fluorite, the pyrite, the calcite, with a typo in it, CaCO3, I apologize. And we have also seen some other minerals that we don't need to list the chemical formulas for. So the mica, the garnet, diamond, apatite, and gypsum. So all of these names may occur again in that Kahoot, along with the shapes such as the cube, dipyramid, the hexagonal shape, and octahedron and rhombohedron. Let me just take a last quick look to make sure we have mentioned everything. We've seen a couple of uses of these minerals, like the hydrofluoric acid for fluorite, right? You can see the fluorine found inside of that fluorite up here. And we've noted that halite is something we consume every day. So any questions, please ask us in the Q&A, and Derek will be able to respond to those. In the meantime, I'll just focus on the Kahoot that we're not about to play now, because the event will conclude in 15 minutes. If you don't happen to win, because we are many attendants today, and many family members may actually want to win this as well on the same screen as yours, don't despair. We'll have the same type of event about a different topic next week. So we'll try to do this a couple of weeks, a series of 6 events. The next one will be called Mine the Precious, where we will be talking about the value of some crystals and some minerals that carry metals. So you will be able to see the questions shortly. Now, this is the real thing. So we want to actually be as quick as possible. Please note that you will have multiple choice questions, or true or false. Sometimes it is important to look at the picture of the question. And please do not forget, if you win, let me know what address we sent the box to. Again, 3 boxes just like this to be won. This is the Minecraft-inspired rock identification game. It looks like we can start. It won't take too long. 14 questions. 10 seconds to go. And off we go. Thank you, everybody, for coming here. First question, 10 seconds per question. True or false? That halite on wood has a salty taste. Everybody knew it. Second question. This is calcite on the picture coming up. Which green technology uses calcite to reduce greenhouse gases? Very good. Next question. Which of these minerals is used to make hydrofluoric acid? And fluoride is the correct answer. True or false? Calcite only has one good cleavage direction. Very good. Most people got it. Which of these minerals has no good cleavage? Pyrite would have been the correct answer. Which is the softest of these minerals? Yeah, most people got gypsum. That is correct. Which of these minerals is the most common one found on the Earth's surface? Quartz is correct. So this is quartz. Which shape do you see? And dipyramid is the correct answer. This is the mineral apatite. Which shape do you see? And the hexagonal shape is the correct one. Hexagon is what you see on that green mineral. This is fluorite. Which shape do you see here? This is pyrite. Which shape do you see? Everybody's got the cube. This is garnet. Which shape do we have here? And the dodecahedron is the correct answer. This is calcite. The second last question. Which shape do we have here? And the rhombohedron is the correct answer. Last question. The race is on. What actually is in that container of this spider plant? So look at the picture. What is that container? "19 people knew it's a curling stone that Derek has researched at the Hartwell School of Earth Sciences." So very, very good. Now the moment of truth. Who's going to win this? Ben, number 3. Ben, I will need your mailing address. Gilby, I will need your mailing address. And number 1, Che has got number 1. I will need everybody's mailing address. Please do not forget to let me know per email or in the private message, I guess. So I thank you very, very much for being here in our event. We do have another 5 minutes if you want to continue, 4 minutes until we close.
Thanks, Tobias. That was really fun.
Thank you, Lynn. Thanks for your comments.
In case anybody wasn't looking at the webinar chat and you were curious about Derek's curling rock research in Scotland and Wales, I put a link where he talks about how he came to study that and why and what his findings were. So when you're finished up, if you have some time, copy that link and have a look at what led Derek to study curling rocks.
Thank you, Lynn. I just put a poll out just to see what do we do next time, when we have Geology Games, Mine the Precious next week at the same time, same Zoom. You can sign up on our website, which is hes.laurentian.ca. That is our website at the Hartwell School of Earth Sciences. We also have socials such as Facebook, Twitter, and Instagram. Follow us under the handles of Hartwell ES for Twitter and LU Earth Sciences for Instagram. We will stay on for another couple of minutes just to answer all the questions. Very good to see. Everybody is going to do playing and learning. So we'll end that poll. Thank you very much. And yeah, sharing the results with you. The poll said that we will do both learning about earth sciences and geology. We will cover a couple of different topics. One of our coming up Geology Games will be about fossils. And you can see when this is being announced on our channels and on our website, so you can play along, and you will have a chance to win again. Tell your friends, tell your family, tell your neighbors' kids, or maybe don't tell them, so you'll have an increased chance of winning it yourself. But thanks for having us. Thanks for being here with us, spending these first session of Geology Games Crystal Clear, which is the foundation of understanding rocks that we will venture into in the next upcoming sessions.
And if you have friends that you want to invite to play along with us next Wednesday, I put a link on our website, as Tobias mentioned, but our outreach events is where you'll find all of the new information when we post the link to register for our next outreach event. That is where you will find it. So we haven't posted that just yet today, but we will soon, and it will also be on all of our social media accounts. So thanks everyone for following us as well. We really love the engagement that we get. And feel free to let us know what kind of content you want to see in the future.
All right, it is 4:45. We'll end the event. Have a good day, everybody. Thank you for joining us.